My name is AJ Gervino, and this is the Studio Stream Analyzer class. We used to call this Tricks of Trade. It's now called Basic Training, and essentially it's the training of probably our most common tool, our most widely used tool, OLI Studio, specifically the Stream Analyzer package in it. And what we're going to do is we're going to go through about a third of the training material today. We'll go through another third of it on Thursday, and then there'll be another third that we're just going to give you in essentially a training manual so you can learn on your own. There's just so much that we can cover in this class that we're not able to do it in 6 hours. So what we try and do is get the most important stuff conveyed over to you, and then the other stuff you can always look at whenever it works for you. Okay, good. So what I'm going to do is just describe, how the training classes will go. Today's 3 hours of training and calculations and discussion. We do it in 3 segments. So we'll go for the first hour or so, take about 5 to 7 minute break, go to the second hour, take another 7-minute break or so, and then finish at the top of the hour. It's 12 o'clock our time. Let's say it'll be 6 p.m. Spain time. And what we're going to do here is go through where am I going with this? I know that I'm going somewhere with this. Yes, we're going to go through the mechanics of the software. I'm going to show you the various feature functions in the tool, show you the user interface, and then just get everybody comfortable to see where all the buttons are, where you add an object, where you press the calculate button, where you find the data from the reports, how you change the chemistry, etc. So that's always number one, getting the lay of the land, as Sun Tzu used to write about. And then what we're going to do is actually do a couple of calculations. And we're going to focus on single point and multiple point calculations on today. And in all, there are about more than a dozen single point calculations. And there are probably, I'm going to say, 30 plus types of multiple point calculations that you can do, depending upon how you set up the calculation. So there's always a lot that we can create with this tool, and we're going to try and do our best to cover some of the more interesting ones today. So before we get started, I have to make sure that everybody has the software up and running on your machine. So let's start by asking, does everybody have a better question? Does anybody not have OLI Studio on their machine right now?
AJ, I do have OLI Studio, but it's version 11.0. I told that Jim earlier. So just help me as much as you can with, I know there is probably the data is uploaded in an older version. Is somewhat slightly different than what you have. So
yeah, there's a couple of differences, but for the most part for this training, you should be okay using 11.0. But it sounds like you're using your own network copy or Flint Hills.
Yes, I have my own. Yes, we have our own OLI Studio downloaded in my machine, so that's what I'm using.
Cool. Okay. Hey, Brett, are you using your own as well, or are you on the Skynet or SkyTech?
Yes, I'm using my own, but somehow I got the latest version. So I got the 11.5.
Good.
And I was hoping, so the first thing that pops up is the first run wizard. Do I need to just click cancel or?
Hit the cancel button there. Yeah, that's not important for us today. It is useful because it helps you set your units, names, the chemistry models, things like that. But for the most part, those are for custom applications, or essentially applications that are specific to a company. So you may want to look at it again when once this class is over.
Thank you.
Joaquin, how about yourself? Are you using SkyTap, or are you using your own copy?
Yes, we have the 11.5 version in the company, so I'm using.
Okay, good. That's fantastic then. So okay, good. So the good thing is that means we don't have to worry about SkyTap not working for you all. And that's kind of like that's the cloud version of the software. that's run by a different company, but we essentially lease out the space so we can teach classes. But okay, good. So we're going to get started. Actually, now, before I get started, I want to get just a general understanding of how much experience each of you have with it. So Brett, let me start with you. How much experience do you have with it?
I have absolutely no experience with OLI. You know, I couldn't get past the first run wizard, but no, I have zero experience. Sean mainly did all our work in OLI, and when he left, it was kind of a big, you know, a big deal. So.
How about the rest of you guys? Any of you have any experience with the code?
As far as I'm myself, zero, no experience at all.
Okay. And who was that
Um,
talking? I'm sorry, I couldn't see.
I'm sorry,
Right.
AJ. What was it?
Who was it? Who is it that said they don't have any experience at all?
Dino Flint
Oh,
Hills.
Dino. Okay,
Yeah,
sorry about that.
yeah, no, I'm
That leaves
yeah.
Joaquin. Yeah. Joaquin, how about yourself? Do you have experience with the software?
I have been using the software since January, so
Okay.
I have 2 months experience, quite intensive experience with the software. But yes,
Okay.
mostly my whole job so far has been the use of this software. So I have a quite at least I have some experience with it.
Okay, good. So Joaquin, you may want to just review what we're teaching in this class to determine, if you're getting anything new from it. Okay, and if not, just give me some feedback so I can at least try and make things a little bit more challenging for you in that case. Okay. And Xingjiang, have you used the UI before?
Yeah, definitely. I use it UI for debugging.
Okay. Gotcha.
Yeah.
Fine, good.
Yeah, so I work with some cases, but I don't have a full knowledge of Studio, I think.
Got it.
Yeah.
Okay. All right. So let's get started then. So everybody should have on your screen right now the OLI flow sheet, Studio rather. And what I'm going to request or suggest is that everybody, we should have done this before today, but everybody have 2 monitors. So let me just start by asking, does anybody not have 2 monitors? Or you can see my screen on one monitor and then your own computer on the other, the own software on the other. Okay, so I'm going to assume until you guys tell me that you can see my screen and then your case file, your software at the same time, because what we're going to be doing in this class is I'm going to be making changes to the software, and you're going to be making the same changes on your version of it. So you're just going to follow, we're going to follow along that way. We have a manual for it, but I find the manual to be, boring, actually, making it very simply. And it's kind of like, why am I even here helping you guys? Because you can just do the manual yourself. So I like I try and make this as interactive as we can. That way you guys are actually forced to look for things, and then you can ask questions as you're looking. Okay. And we all generally finish at the same time that way. So anyway, okay, good. So I'm going to get started on my screen here. And what I'm going to do is just walk you through the interface. And there are about maybe 3 different layers or sets of screens that I want to walk you through. So it may take maybe 5 or 10 minutes to do this. Okay, first of all, this here is the primary interface to OLI Studio. The OLI Studio has panels across the edges and of course a main panel in the center. The panel along the far left over here called Navigator. What the purpose of this panel is to show you what files you have open at a given time. And also within each file, what calculation object or stream object you have inserted in it. Right now, you should have a case file labeled document1. It hasn't been saved yet. And there are no objects in that case file. You have a single header in the case file called streams. You can look at that streams as being kind of like the default settings, or the place where you set the defaults for your case file. Okay, so for example, right now in this case file, if I were to look at my units, I'm just going to click up here where my units manager is, sometimes called units mangler, but that's more of an internal joke. What you can see when you click on the units manager, here at the streams level, it's just showing you that when you create a stream, it will have this type of units. If you create a water analysis, it'll have this type of units. If you add a mixer, it'll have this type of units, etc. Okay, so the value of the top level streams is that it gives you a place where you can make changes to your file before you create anything. So whenever you're creating an object or a calculation, it's got either the right chemistry or the right naming or the right units that you want. Okay, let me just continue with that just for a second. This object here is called the names manager. Here, for example, what you can do is instruct the software of how you want information presented to you, whether it's you're entering the information or whether you're looking at it in the report. And the default here is what's called the OLI tag name. That's the variable name that in fact Xingjiang uses inside the engine. Okay. Yeah, that's kind of like our internal variable name. Okay. You can also at the stream level set your chemistry model options. And there are a lot of options here. We're not going to go through any of them right now, but you can see at the top level stream level, I could change the thermodynamic framework I'm using. I can add any custom or private databases. I could turn on or off redox. I could turn on or off generalized phases like the water, vapor, solid, second liquid, etc. Okay. So this top level stream can be really useful because then what you do is you set your defaults here, and then you don't have to change it every time you create a new stream or object. Okay, enough of that. Below the navigator is the actions panel. The actions panel is where you either add a stream object, a mixer object, or any type of calculation object. And in order to do anything in the software, you have to add an object. And the objects are either going to be streams, and the streams are like containers. They contain the material that you want to test. And then you'll also, after you create a stream, you'll create a calculation object. Calculation objects operate on the stream that you create. So what you're going to notice with the software is that you create a stream, but you can't do a calculation in a stream. That stream is just essentially to set your material. In order to do any kind of meaningful calculation, you add a calculation object. That object takes the information from the stream and then runs whatever calculation you want with it. Okay, that's the logic of the software. I'm going to go back to that in just a second. Below that is something called the plot template manager. Now, when you do surveys or mixing calculations, you're going to generate plots. And sometimes plots, you can have plots that are common to you, like, for example, a pH survey, or you may be looking at the amount of solids that come out of solution, or the scaling tendency of a solid, or even like a corrosion rate calculation. And you may actually modify the settings of the plot so that it's presented in a way that you either want to interpret it or in a way that you want to present it, let's say in a report. What you can then do is, with the plot template manager, is save that format. So if you ever do another type of calculation in another object, rather than having to reformat it, you can just apply that template to the new calculation that you did, and essentially you save yourself a lot of time. Okay. Down below here, this is the calculation output window. This is really useful, especially when you have problems. So let me say it another way. This calculation output is like a lawyer. Everybody hates a lawyer until they need one, right? Same here. You don't want to look at this until you need to. And that's generally, I'm not sure how that analogy works, but anyway, that sounded funny to me. The purpose of the calculation manager output is just to inform you of how the calculation is proceeding. There's black text, there's green text, there's blue text, and there's red text. Black text is essentially informative. Things are working, it's telling you what it's doing. Green text is just telling you what it's successfully completed. Blue text appears when it needs to give you a warning. And then red text is when you have a calculation failure. And that's telling you why something failed. Okay, so it can be quite useful looking at this calculation output when something doesn't work. Okay, it's not always instructive, but at least provides you with some information about, oh, maybe I forgot to add a component or forgot to turn redox on or turned off a solid that I wasn't supposed to, things like that. Okay. Now, middle screen here, this middle panel is the main worksheet. And the purpose of the main worksheet is where you enter your data and you do your calculations. Right now, there's not a whole lot shown on this, and we'll take a look at it in just a second. But you'll notice on this worksheet that you're going to have multiple tabs. And there are about maybe half a dozen types of tabs that you can view, depending upon what calculation you're doing or what stream object or what object you're looking at. And we'll take a look at all of those tabs during the course of the day. Okay. Across the top here, this top here is the ribbon button. And the purpose of the ribbons are to give you quick access to certain, what am I trying to say? Quick access to certain features and functions. Here, for example, these here you'll recognize as normal Microsoft functions. This here is, again, this is like new file. This is open and close. This is funny, save rather. This here is a floppy disk, a hard floppy disk from the 90s. So it's funny that we've actually saved this icon as being a save on something that we don't even use anymore. I used to call that a 3.5-inch floppy disk. And it wasn't even floppy, it was a hard disk. Then going over here, you'll have different other types of options, like these buttons here enable you to turn on or off certain phases. We'll chat about that later on. These buttons here allows you to turn on or off redox. Here is where you change the chemistry of your system. For example, I can either use a framework called MSE, one called MSE-SRK, or AQ. We're really not going to worry about that in this course today. We're just going to stick with MSE. But essentially what we're talking about is old technology going to new technology. And then these ribbons over here is searching for information or components, names manager again, units manager. This is essentially a toolbar customizer. Not many people use this, so we'll just ignore that for now. This is options. This is tools and options from the menu. Okay, this is actually quite useful, this button here. And there it is. This actually enables you to set the conditions or the settings of your case or of the software itself. Okay, there's a lot to talk about here, so I'm not going to try and jump into it yet. We'll talk about that later. And then lastly, when you're in a calculation, there is a button there called Calculation Options, which is really a good feature function because that enables you to turn on certain types of calculations. Like, for example, there's one for scaling nucleation induction time. There's one to turn on the diffusivities of materials or the Gibbs energy of materials. So not everything is calculated every time you run do a calculation run, because that takes up runtime. And so we keep the most important things on by default, and then you can add additional properties to the calculation as you need to. Okay, let me stop there because I spent about 10 minutes describing the screen. Do you have any questions so far about what I'm talking about? Okay, good. Let me keep on going. And then lastly, we're going to have this menu bar here. So again, file, edit, these things are obvious. Okay, don't worry, I don't have to describe these. These two menu items here, streams and calculations, these are ways of adding an object. So I can add a stream object, I can add a water analysis, I can add what are called ScaleChem objects. And you'll notice that these objects are the entries that I was describing before. Okay, and then you have calculations. Calculations, again, are those operators that we were describing. So you have a single point, a survey, chemical diagrams, mixing. Okay, these are, again, if you just take a look at this here, 2, 4, 6, 8, 10, there are 10 objects on that one. There are 4 objects on that one. There should be 2 on that one. A mixer is just by itself. So again, you can see you can add objects to the navigator panel. But you'll also notice that OLI generally has at least 2 ways of doing things. So these two menu items here are essentially identical to the actions panel here. Okay? And in fact, there'll be a third place you can do things. Okay, so keep in mind that whatever's convenient for you, you'll either use the menu to add objects and streams and calculations, you'll use the actions panel, or a third one I'll show you in just a second. Okay, the next menu item is called the chemistry menu. And this is actually really important because when you are studying the process, you again may need to turn on private databases or custom databases. Here, for example, is a PFAS database. It's a custom one. It's empirical in nature. Here's another one called activated carbon. So you may find that sometimes you want to use more than just the public database that OLI is providing. And these databases may be something that OLI created for you or you created yourself. And this is where you add those. Likewise, in certain instances, you may need oxidation reduction turned on. All three of you are interested in redox chemistry, in corrosion. So that means redox chemistry is implicit in the in that process. Therefore, redox, you will want redox on in your corrosion calculations, and therefore you'll want to make sure that these buttons are clicked. Although there's more to it than what I was just describing. But this is, again, the chemistry model options is where redox is turned on. Phases. It may not seem obvious to you, but in certain cases, you may want to turn on a solid or turn off a solid. What I mean by that is, and they allow it to allow a solid to form or disallow a solid to form. If I look at it from a corrosion standpoint, you may determine in your process that iron carbonate, a common corrosion product, won't form because the kinetics are too slow. So you will, in fact, instruct the software to tell it to not allow iron carbonate to form simply by checking a box or unselecting a box. Now the software will do a calculation, but iron carbonate will not be allowed to precipitate. Or taking an more interesting one, let's say you've got a sulfide in the system, a sour system. And so you have got there are about 5 different phases of iron sulfide that can precipitate, anywhere from amorphous iron sulfide to McKenowite to marcasite to pyrrhotite to greigite, etc. And so you may choose, or you may know in your process which one is actually the one that forms, even though that one may not be the most thermodynamically stable. So you would turn off the others in order to make sure that that one forms in your process. Kind of like being omniscient, all powerful. Right, you can determine for nature what solids are forming there. Anyway, so we're not going to deal with this too much this week, but this is an important feature function that the software uses because it allows us to bring in what you would call non-ideal or non-equilibrium factors in an equilibrium calculation. Right, in an equilibrium calculation, we're always going to the most stable state from a thermodynamic standpoint. And that most stable state may in fact not be the most the state that you actually see in nature or you see in your process. So sometimes we have to thwart nature and say, sorry, what we're predicting is not in fact what I'm seeing, so I've got to make the change. And rather than add kinetics to it, you just turn off solids. All right, let me stop again because I've spent 15 minutes now discussing it. But hopefully what that does is it gives you, let's say, an indication of what the screens look like, what, again, the menu items look like or actions look like, and why you would take certain actions. All right, now what we're going to do first is we're going to start with chapter 2 of the manual, and that chapter 2 is called single point calculations. And we're going to go through, I don't know, maybe 8 or 9 different calculations in the next hour or so. And then we're going to move to the survey calculations. So let's start. Every time you come to the software, you're going to have to you have to enter information, and that information could be some sort of material composition. The way you enter information is most likely going to be by either a molecular stream or by a water analysis. Either you have a stream like I've got 20% sodium hydroxide, or that's a stream. Okay, I'll add sodium hydroxide to water, add a 20%. That becomes a stream. Or I've got a water analysis, and that analysis could be seawater. It could be anything, quite frankly. But you have the data from the lab that says I've got so much sodium, so much calcium, magnesium, etc. And now that information has to be put in. Or there's a third way, and the third way is when you import data. You can import data either from OLI's other software that we're not showing today, or you can import data from other software. And the two most common are going to be HYSYS and Aspen. Okay. So you can take a stream from a HYSYS run, bring it in here, and then operate on that. All right, but if you're not worried about that, or if that's not part of your interest, then we don't have to worry about it. We're just going to focus on streams and water analyses as ways of entering information. Let's start now by adding a stream. Okay. So I double-clicked on the action panel, add stream, or I could have clicked on streams, add stream here. Either way works. Now, I want to just introduce you to the grid. Okay, again, this is for the new folks. I realize that Joaquin, you're already familiar with this. Jingjiang, you already know this as well. So just bear with me on this one for now. Okay, the inflow, there is a tab in the stream, and actually in every object, that we call the grid. The grid is essentially what you see here, just a table where you have variables and you have values for that variables. And then you're going to have different chapters or different categories in the grid itself. So right now I've got two categories in this grid, a stream parameter category and then an inflows category. Stream parameters are self-evident. It's the total size of the stream, and that size could be mass, moles, or volume. It's the temperature at which the stream is set, and it's the pressure at which the stream is set. Okay, and then below that are your inflows. And the inflows essentially is the composition, nothing more complex than that, although it can be quite complex trying to make things work. Okay, you'll notice that there are hyperlinks to all the units. And if you click on the hyperlink, it brings up the units manager. Okay, we'll have to spend time going through the units manager, but I want to avoid that right now. Okay. And then, of course, on the right-hand side, there's the value there, how much is contained. Just want to say outright, every time you create a stream, that stream will start by default with 1 kilogram of water. This number here, which looks essentially arbitrary, 55.50824711006 double precision, right? Thank you, Jingjiang, is 1 kilogram of water. That's essentially all that is. But our software works in moles, and so we will start the default calculation or default setting in moles. Okay, but you can change it. Remember, you're talking about the wizard at the very beginning. You can change your units there. You say, nope, not interested in moles. I always work in concentration, and then you never have to see it again. On the right-hand side here, you're going to have your calculation section. In the upper right, always in the upper right, you're going to see either the calculation settings or the calculation button. Okay? So once you put everything in, you're going to just essentially divert your eyes to the upper right because that's the next area that you're going to work in, okay, or operate on. Okay. A little below that, you'll see a summary section. That summary section is going to tell you how the calculation is set up, what units are used, what chemistry model is being used, if solids are selected or deselected, if redox is turned on, if phases are turned on and off. Okay, and then also you'll see more salient or more interesting information once the calculation is done here, like how much material is in the vapor, aqueous, or solid phase, or oil phase, what the pH is, what the density is, how long it took to calculate, things like that. Okay. And then
AJ, I'm sorry, I have a quick question.
Yeah.
About the redox. When we have the redox turned on, does that automatically will account for the electrochemistry of the stream composition and data available there? Like for
That's
example, right. Okay, perfect.
Yeah.
Thank you.
Now there's more to it than that. In fact, it's got a couple of different layers in terms of trying to explain it. So we'll just leave it at that. When you turn redox on, you're doing what you want to do electrochemically. Okay, and then maybe Wednesday, if we can't get to it today, we'll talk more deeply about what redox does or how you can modify the redox settings. And so, actually, I feel like I kind of left you in a kind of like you're watching a TV show, and then you got to wait next week for the for the final story. So let me at least tell you the final story, so you don't have to wait for next week. The idea is redox, you turn on redox, but by turning on redox, it doesn't necessarily mean that every oxidation reduction reaction will take place. What the software does is when you check that button, the software will turn on oxidation reduction for water, for sure, right? And then it'll turn on redox for transition metals. It does not turn redox on automatically for the left-hand side, group 1 and 2, and 5, 6, 7, and 8. Okay, and so you just turn those on manually. It's just a checkbox. But then that's layer number 2. Layer number 3 is more interesting. Let's say, for example, you're looking at sulfur chemistry. So you've got, I think, like 8 oxidation states for sulfur, right? You're starting with H2S. It could go all the way to persulfate, S+7, I think it is. But you know, in your process, and I'm thinking actually Tenaris in this case, that you can probably get oxygen to oxidize H2S to elemental sulfur, but that's where it stops, simply because you can't get the concentrations high enough or the reaction rates are just too low. Okay, so what you can do inside the redox function is you can tell the software that I only want the redox half reactions for elemental sulfur and H2S, and that's it. I can tell the software I don't want thio to form, I don't want persulfate to form, I don't want sulfite to form, I don't want sulfate to form, etc. So essentially you can limit the extent to where the redox reaction, what redox reactions can take place. Okay, so that's step number 3. That's level number 3 in the redox function. Okay. And there's good reason for doing that. And if hopefully we get a chance to actually play with that, let's say sometime between today and Thursday. And lastly, just to let you know, if you're doing corrosion calculations, redox is turned on automatically. You don't have to actually go click on it. It knows to add it. But just keep in mind, it knows to add it for the transition metals. So oxygen for the iron, chrome, nickel, main ones, moly, things like that, manganese. Okay, keep on going here. So right now we've got a stream present, and what we're going to do is we're going to add a very simple calculation. The purpose of doing this calculation is to get everybody comfortable with essentially doing a flash calculation and then looking at the results, and then actually looking at what OLI does when it does a calculation. What I mean by that is I want to talk about the speciation and activity coefficients that are happening either in the report or essentially under the hood. So we're going to start by adding ferric chloride, FeCl3. Everybody add ferric chloride to the water, okay, and add 1 mole of it. Okay, so that's about 167 grams of iron chloride in water, 16%. No, that's not true because it's 16 over 1160. Okay, so let's say 14 or 15% ferric chloride. Okay, that's it. That's all we can do here because I don't have any way of doing a calculation. Rather, I have to add a calculation. So like I was saying before, you can either add a calculation using the action panel. You can use the calculation, add a calculation from the menu, or you can add a calculation in the upper right here. There's a little drop-down button called Add Calculation. And you're going to add a single point calculation. Right? Now, what's happened is a single point calculation has now found itself underneath the stream that you created. And that stream that you created is underneath the global stream of the file. So you can see that's a hierarchy developing here. Okay? What that means, the cool thing about that is, what the software knows to do is to pass information from the higher level to the lower level. So if I were to set the units manager the settings here, it knows to apply them here. Likewise, it knows to apply them here. And also, if I set the stream composition here, right, 1 mole of ferric chloride, it knows to transfer that information downward as well. On the other hand, I want you guys to do this with me right now. Just type in O2 for oxygen. Okay. Oxygen, you'll notice, is in a cell that's now colored white compared to the ferric chloride, which is colored yellow. Yellow cells are not editable. And in order to make the change here, I would have to go back up to the top level and add or edit the ferrochloride here. Likewise, anything changes you make at the lower level does not make its way up to the upper level. So the oxygen I added is not at the stream level. Information is passed downwards, not upwards. It's also not necessarily passed across. If I were to create another stream, if I were to create another single point calculation, right, from that stream, the ferrochloride's there, but the oxygen is not. So the general idea is that do as much as you can at the stream level. That'll save you steps that you need to take when you're at the calculation level. Okay, especially if you're going to be running multiple calculations. Okay, good. All right. So I'm going to delete the oxygen here just by clicking on the cell and pressing the delete key. I don't know if you noticed, but when I added that stream before, I added that calculation before, right, to do a comparison. Once I knew I didn't want it, I just right mouse clicked on it and pressed the delete key. And one of the things you're going to notice is that right mouse clicking in areas, right? Sometimes I don't know where to click. You'll notice that there are options available to you, where depending upon where you right mouse click. Okay, so if I were to right mouse click on a single point, I've got these options. Right mouse click on a stream, I've got these options. Right mouse click on the grid, I get these options. It's kind of cool. They become really helpful, those right mouse clicks. Good. All right. Right, we're already 45 minutes into the class and we're ready to do our first calculation. Maybe that's why they asked me not to teach anymore. Anyway, let's try it out. Press the calculate button. And right now what the software is doing is it's taking the information that you added, it's going to the primary database and generating a chemistry model, which means it's looking for all species in the database that has hydrogen +1, oxygen -2, iron +3, and chloride -1. It's compiling that information and putting it into a local model. And it's also adding any chemical reactions and any species, again, that are important to it. And so now it's created a local model. It's now applying that local model to the composition and conditions we gave it. And now it's coming up with an output. Okay. From a calculation standpoint, you can see starting the calculations. It's setting up the chemistry model. It's generating that model, right? When it goes past that point with no error, it's now setting up the single point calculation. It's telling you essentially what how it's defined, and then it completes the calculation. Everything worked as expected. And then if we look on the right-hand side here, again, generally what you do is you press the calculate button and you'll just start looking in the summary section for results. Because the summary section sort of gives you as a snapshot idea of what was computed. So here, for example, we find out that this composition had a pH of 1.5, and it had a solid phase as well as the water phase. Okay, the density is about 1.12, and it took about 3 seconds to calculate.
Hey AJ, I'm having a pH of 2.2. Is that the difference? Excuse me. Is that the difference you were talking about between 11.5 and 11.0
That's right.
packages? Okay.
That's right. So look across the top here. Actually, look over here in the summary section where it says automatic chemistry model. Yours will say AQ framework, AQH+.
Yes.
Right. And now we've transitioned in 11.5 to the MSE framework.
Okay.
And the reason we did that is because the MSE is just a more robust framework. It's going to give you better results. But the reason you see a difference is mostly because it's not that your results are wrong. It's that the old AQ framework or database has certain solids in it compared to the MSE, which have another set of solids. And what I mean by that is there are certain solids in the MSE framework that are not in the old AQ framework. So you're kind of getting different results simply because you have fewer solids in the older database than you have in the newer database. And as a result of that, you're getting different pHs. Okay, so what I'm going to ask you to do right now is go back to the top level stream here. Okay, so click on this top level stream, and then you're going to click on chemistry model options. And then you're going to change your thermodynamic framework from aqueous H+ to MSE. and then press OK. Now what that's going to do is that's going to set your file to always make MSC streams from now on. But your current stream doesn't get adjusted. So we have to do the same thing at this stream. So now click on your current stream, right? Click on chemistry model options again and change that from aqueous to MSCH+. Once you do that, then the stream gets adjusted. You should see your single point calculations go away. So go back to your single point calculation and recalculate. And confirm with me that you see the MSC framework here, and that when you calculate, you get a 1.5 pH.
Confirmed.
Good. And honestly, guys, the difference is, if I remember right, this one has a crystalline iron hydroxide in the database MSC. So I think we have goethite or ferrihydrite in this database, but in the old AQ database, all we had was amorphous iron hydroxide. FeOOH was only in the corrosion and the geochemical database. Okay, but we made changes over time on that. Okay, good. All right, let's take a look at the results. This is why I went through all this time. To me, it's kind of like we're sharpening our axe in order to do more important work. But in order to sharpen our axe, we have to know where things are, why things work the way they are, and also how to now look at the data so we get what we want from the calculation. Click on the report now. Okay, again, I mentioned there are roughly about a half dozen different types of tabs. Some of your tabs will be observable, some like the file reviewer are not, and I can show you how to get that if you want. But the purpose of the report is essentially for the OLI engine to dump the information they've computed into a readable report. So this is where Xingjiang comes in to essentially do these calculations. Then the output that he generates is sent to the code that the developers, the UI developers, work on to create these formatted reports. So that's how our team works together. So now what you can see here is that the way the information is consumed is through what you would call chapters or sections or categories. There's a category called stream parameters, right? These are kind of like the properties of the stream. Then there'll be a category called total and phase flow. Essentially, it's the amount of things, and the amount is going to be either in moles, mass, or volume. Below that, you're going to have what we commonly call scaling tendencies, or the propensity for materials either to precipitate or dissolve. Okay? Or what I should say is phases to precipitate or dissolve into your solvent. Actually, it's vernolite. Okay, I had it wrong. I thought it was something else that was precipitating here. Anyway, we'll get back to that. And then below that is the species output table. And the species output is essentially what we know as the speciation. If you were to take essentially if you could essentially look in that water to see how much of different species or components existed, this is what we're calculating exists. We have so much essentially free water, so much free chloride ion, so much of the iron chloride complex, so much of an iron hydroxide complex, etc. Okay. I'm going to actually ask you to just a second about how you're viewing things, but let me keep on going. And lastly, we have a table called the element balance. When you've got multiple phases present, the element balance is a good way of doing actually two things. One, identifying where the material is across those phases. For example, how much iron is dissolved, how much iron is actually precipitated. Okay? Or how much of the different, what we call material codes, is present. Material code is essentially the element at its specific oxidation state. So right now we have iron in the +3 oxidation state, and that's it. But if in fact I turn redox on, I would see iron +2 here, and I can see what the relative distribution of iron +3 to iron +2 is. Okay. That would help me understand ORP.
And AJ, a
Yeah.
rudimentary question. If we have a vapor phase here, it will also indicate a vapor phase and the appropriate speciation, right?
Yep, exactly. Yeah. And that's actually kind of cool because when you start using vapors or even oil phases, then you can see the 4-phase distribution of materials. And that happens, we do that a lot, especially when it comes to carbon dioxide, water, and H2S. Now, where is the H2S partitioning? And especially with upstream production, it's then a question of, okay, is my oil, my crude oil, acting as a source and a sink of H2S in my water phase? And will that make corrosion worse or easier, or scaling worse or easier as I produce the well, as the fluid flows up the well? So yes, all that stuff's done in total. And the last thing, what I want to do is I want you to notice that you've got buttons in the upper right here. Let me just dismiss the export button. The purpose of the export button is just to send the data to something like a spreadsheet file, an Excel spreadsheet. Don't worry about that too much. You can also just Control A, Control C, and Control V over as well. Okay, there's always ways of getting the stuff out of the software. But the other one that I want to focus on is the Customize button. The Customize button is really important because I just showed you, all I did was to show you 6 categories of information. Okay, there are in fact 30, I think there are about 30 different reports or report sections. Only 6 of them are turned on. So if you needed to know about activity coefficients, gas phase fugacities, partial pressures, equilibrium constants, etc., you turn those on there, and then you can see what the rest of that chemistry looks like. Okay, so you can always dig into the software for more information if you want it. Our responsibility when we create the UI is to make sure we're showing you the most important stuff without inundating you with stuff that we don't think you're going to need to see, at least not at first pass. And if you do need to see more information, you can always add it here in the custom calculation. And like I was saying before, in the calculation options, you can turn on the specific set of properties that you want calculated. So it's not always best just to calculate everything and then show you everything, because that's a quick way of you saying, hey, TMI, too much information. Let's go ahead and, let's pull back a little bit. And so what we've tried to do is come up with a balance between just enough information, but at the same time, giving you the ability to add more. Okay. Now, question to you. When you look at, let's say, the species output, do you see these variable names, or do you see a different variable name? Like, do you see Fe+3, or do you see Fe ion?
The latter from my end.
Thanks. And is that everybody's case as well? Okay,
Fe+3.
Perfect. All right, good. What I'm going to do is I'm going to have to change my settings here real quick. I'm going back to the top level stream, and I'm going to change this to formula view. So my view looks just like yours. Okay. But again, it doesn't change the settings here. So I'm going to do it one more time. Oh, it did change it. Okay, see, I was wrong. All right, learn something new every day. And now hopefully I see the same stuff you do. Good. All right.
Hey, Jay.
Yeah.
I'm sorry.
This is good.
Maybe the way I see it in the species output table, I see it actually spelled out. Iron 3, monochloride ion +2. So the whole kind of thing spelled out in a Word format.
Good. Okay. Reading it that way, you're going to start reading War and Peace with the software. So what you're going to have to do now is I want you to do the same thing I did. Go to the top level stream, then go to the names manager and change it to formula view. That'll eliminate that. Now, it's sometimes useful to look at descriptive names. We normally call that display name. We're going to use formula today because we're dealing with mostly inorganics today. But as it turns out, if you do a lot with organics, I have found, it's my experience, that display name is easier to distinguish organics. Because, for example, I can't tell the difference between N-butane and isobutane by a formula. They're both C4H10. So therefore, Isopropane rather. Right? Anyway, so the point is sometimes it's better to use the descriptive name rather than the formula.
Good point. Good point.
Okay, good. All right. Now, what do I want to do next? I want to ask questions. Did everybody, are there any questions to you guys about, how you then add a stream, add a calculation, and let's say, apply anything? Is there any questions in your head right now that you want to ask? Anything about, let's say, the stream parameters that are calculated, or the speciation, or anything else that comes to your mind?
Not for me.
Good. All right. This is what we're going to do then. We're going to move to our next calculation. Okay. Again, we've got a whole bunch of them to do, so I don't want to necessarily belabor on this, but this was the most important one to do because it's got kind of like sets the table in terms of what how the software works. Okay. What I want you to do now is I want you to rename the stream that we just created so we can just get things organized. And there are a couple of ways of naming things. You can either double click on it to edit it. You can right mouse click on it to rename it, or in the description tab here, you can rename it. Let's just call this one isothermal. Actually, call it isothermal flash, just so it's more descriptive. Because the purpose of that calculation was just to show how a normal isothermal flash is run. Okay. Now, just for grins, let's change let's edit the name of the second of the actual calculation in the stream, and we'll just call this one FeCl3. So we did an isothermal flash of an FeCl3 stream. Okay, now we're going to add another stream. Here's another opportunity to show you something. And I want everyone to be at the single point calculation level. If you're there, I want you to look at the action panel. The action panel is currently blank. Again, the vision of the developers is that, well, you know what, if I'm trying to make this action panel useful for the user, therefore I will populate the action panel with objects that can be used at the level that they're at. If I'm at the single point calculation, there's no further action that I could take at this level. So the action panel is blank. If I'm at the stream level, I can either add another stream, a mixer, or add some calculations to it. If I'm at the top level stream, then I can add pretty much any object that I need to enter material. So there's no calculation shown here, but I've got the ability to add a stream, add a mixer, add a water analysis, add a scale chem object. Okay? So just keep note of that there's a certain way, a certain logic that the software uses. And the purpose is to make it more intuitive for the user. Sometimes it may not look that way, but in fact, that's the way we try and think here.